So this is MCV4U, Unit 12, Assignment L, page 213, number 4, question H. So the question says, use the algorithm for curve sketching to sketch the following. So we are doing H. Alright, so this is the question. So f of x equals x plus 3 over x to the power of 2 minus 4. So from this we can already establish a few things. We can establish our vertical asymptote, our horizontal asymptote, our x-intercept, and our y-intercept. So for our vertical asymptote, we take the denominator and let that equal to 0. So x to the power of 2 minus 4 equals 0. X to the power of 2 equals 4. We square root both sides and we get x equals positive or negative, positive and negative 2. For horizontal asymptote, because we know horizontal asymptotes, if the numerator's degree is less than the denominator's degree, a horizontal asymptote is always equal to 0. So horizontal asymptote is y is equal to 0. For x-intercept, we let y equal 0 and just solve for the numerator. So x plus 3 equals 0, x equals to negative 3. And then for y-intercept, we let the x values equal to 0. So we have positive 3 over negative 4, which is equal to negative 3 over 4. So now that we have the vertical asymptote established, horizontal asymptote, x-intercept, and y-intercept, we can move to the first derivative. So using the first derivative, we can find the local maximum and minimum points. So from this, we'll use the derivative rules. We take the beginning function. So we take the derivative of x plus 3 multiply by x to the power of 2 minus 4 minus x plus 3 times x to the power of 2 minus 4. Oh, the derivative. Sorry, that's my mistake. The derivative of x to the power of 2 minus 4. So we just carry that out. So the derivative is 1 times x to the power of 2 minus 4 minus x plus 3 times that derivative of the beginning one, which is 2x, and then we just continue that, and we just continue that all the way down, and we get an answer of negative x to the power of 2 minus 6x minus 4 over x to the power of 2 minus 4, all in brackets to the power of 2. Okay, now to find the local minimum and maximum points, we just use the top part and we factor. Unfortunately, it doesn't factor out to whole numbers. It factors, so we have to use the quadratic formula. So over here we have the quadratic formula. To make it easier, I just factored out the negative because I don't like dealing with negatives. So instead we have x to the power of 2 plus 6x plus 4. So using the quadratic rule, we fill in for the variables, and then when you go through the whole process, you come to the two different local minimum and maximum points that are possible, which is negative 6 plus the square root of 20 divided by 2, and then negative 6 minus the square root of 20 divided by 2. And from there you get decimals. This one is negative 0.76 and negative 5.23. So we know that the local minimum and maximum points will be at x when x is equal to negative 0.76 and when x is equal to negative 5.23. So to solve for the actual local minimum and maximum points, we just plug in these values into our original equation. So over here, if we just move down over here, we have the original equation, and we plug in negative 0.76 into our x values, and we get a y value of negative 0.65. We do the same thing, but using our second point, which was negative 5.23, and we get a decimal of negative 0.09. And just remember that it's not negative 0.9, it's negative 0.09, because that changes your whole answer. So we get So our local minimum and maximum points are negative 0.76, negative 0.65, and negative 5.23, and negative 0.09. Now we're almost there, we can almost graph it, but we need to know where the graph increases and where the graph decreases. Now we can draw a table, and then using the table we can show which intervals are increasing or decreasing, or we can use values that are extremely close to the vertical asymptotes and plug them into the equation to create points that will show whether the graph is increasing or decreasing. So our vertical asymptotes are negative 2 and positive 2. So we can start with negative 2. So we know coming from the left side of negative 2, the closest number we could possibly get would be, let's say this is a pretty close number, so we can pick negative 2.001 plus 3. We plug negative 2.001 in our x values, and we get a positive number of 247.43. So we know that when we approach from the left side of our vertical asymptote of negative 2, the value will be increasing. So now we do the right side of the vertical asymptote of negative 2, and the right side would be negative 1.999. Once again, we just pick any large value, large negative or positive value, according to our vertical asymptote. So the closest one would be negative 1.99. We plug that into our x value, and we get a y value of negative 250. So from that, we know that on the right side of the vertical asymptote of negative 2, we know that it is decreasing. From vertical asymptote of positive 2, we do the same thing, but instead we approach from positive infinity. So that means we would have on the right side of vertical asymptote of 2, which would be 2.001. Once again, we could pick any large positive value or any large negative value according to our vertical asymptote. Plug that in, and we get a value of 1,249. So we know that from the right side of the vertical asymptote, it is increasing. And then once again, we do the same thing, but from the left side of the vertical asymptote of 2, so 1.999, we get negative 1,250. So we know that it is decreasing. Alright, so now that we know all of these things, we can begin to graph our equation. So I've drawn out a graph already, and I just want to label some specific points that we have here, important points to drawing our graph. So we know that our vertical asymptote is negative 2 and positive 2, so we have the dotted line here. We know that our x-intercept is negative 3, which is right here. We know that our y-intercept is negative 3 over 4, which is approximately right here. And we know our local min and max points when x is equal to negative 0.76. So almost there to negative 1, so negative 0.76 is around here. Our y value is negative 0.65, so right before negative 3 over 4, so right around here. So that's 1. And then when x is equal to negative 5.23, so just a little past x right over here, the y value is negative 0.09. So it is very close to x value. Like, unfortunately, I can't draw it that close, so we'll just put it right there. Now we can start drawing our graph. So we know, because we use large positive and negative values and plug them into our equation to check whether the graph is increasing or decreasing, we know that from the left side of the vertical asymptote, negative 2, negative 2.001, it is 247.43. So left side of negative 2, 2.001, that means really close to the 2. It is positive 247.43, so we know it's all the way up here. And now we know it is increasing. So we can draw our graph. Sorry, I'm holding the camera while I do this. And just connect all the points to connect the line to all the critical points. So we know it has to intercept 3. And we know that the local min/max is at negative 5.23. Sorry, it's just really hard to draw while I'm holding a camera. And then it just continues the line all the way down. And there you go. That's one part. From the right side of negative 2, once again we refer to the large positive and negative values we input according to our vertical asymptote. So negative 1.99, which is the right side of the vertical asymptote of negative 2. We got a y value of negative 250. So we know that the right side, this side right here, of the vertical asymptote, 1.99, really close. The y value is negative 250, so all the way down here somewhere. So we know that it was all the way down here, so that means we can start it. And we know that one of our critical points is a local min or max, which is at this point right here, which is negative 0.76. And then we also know that our graph has to intercept at negative 3/4. So we can continue that line all the way through negative 3/4 right there. Sorry. And then from there, we go back to our large positive and negative values we input into the equation to check where it is increasing and decreasing according to the vertical asymptote. So we are now approaching the left side of the vertical asymptote of positive 2. So the left side would be 1.99. So at 1.99, our value is negative 1,250. So at negative 1.99, which is right around here, pretty close to 2, it's all the way down here somewhere. So we know we have to draw our line approaching the vertical asymptote as it decreases closer and closer to that point that we established. Finally, we can draw the last part. Approaching the right side of the vertical asymptote of positive 2. Once again, we refer back to the values we used earlier. Sorry, the camera's getting kind of blurry now. Oh, what happened? Oh, there we go. So 2.001 is the value we used. So very close to the vertical asymptote of 2. The y value is 1,249. So we refer back to our graph. Vertical asymptote of 2. We picked 2.001, really close, really close. We got a y value of 1,249. It was somewhere up here. So we know that it was approaching the vertical asymptote of 2, and it starts here. And then basically all we have to do is draw that according to our graph. And once again, we have to remember our horizontal asymptote is 0. So we know that it can't touch 2 and it can't touch 0. So we just draw that like that. Sorry, my hand's kind of wobbly right now. Obviously, it's supposed to be closer to the line. And that is basically it. And if you want to double check your answer, you can feel free to just plug in the equation right into your graphing calculator. So let's just do that right now. The original equation was x plus 3. Oh, sorry. Bracket x plus 3 bracket divided by bracket x to the power of 2 minus 4. And we just graph that to make, oops, sorry, minus 4 bracket. And just graph that and make sure our answer is correct. And there you go. That is it. So if we compare that to our question, we have, oops, sorry, I should probably move that a little bit closer. Alright, so there you go. We have the right side right here. The right side right here, our vertical asymptote at 2 follows the line that they have right over here. Our bottom part also follows it and approaches and intercepts at -304 right there. And their maximum point is right over here, just like ours, right over here. And then they used a vertical asymptote of -2, and this is approaching it as well. This comes down and approaches and intercepts the x-axis right here. So that's basically it.